In this example, I'm going to be using WPF to demonstrate both cancellation and resynchronization onto a UI that has thread affinity, such as WPF. If we were to look at the main window, the design is fairly straightforward. I simply have a WPF window with a uniform grid and 12 text boxes. Now, each of these text boxes will contain the source of various HTML pages that we're going to load. If we were to go into the CS file, the backing file for that main window.xaml, you will see we have a cancellation token source, which I'll talk about later. Just be aware, it is a variable we're going to use to monitor cancellation. I have an array of text boxes. Now this particular array I'm just using for convenience sake. That allows me to have a link to each of the text boxes that was in the form I just showed you. And then I have 12 URLs which indicate the websites I'm going to load. Now I don't have any particular interest, except for obviously in the UCSD arena, with any of these particular websites. I just put down what just came to my mind. Oops, let's fix this one here. Got overzealous with the HTTPs. In the main window constructor with WPF, you'll always see the initialize component call, which sets up the window. Then after the window has been set up, I basically create that text boxes field by putting in a reference to each of those 12 text boxes that you saw when I showed you the designer. Now we're going to skip over this method called download web page for right now because we want to get down to the event handlers. First of all, there are two of them that we're interested in. I'm going to go to the cancel button because it's the simplest one right now. Remember that token source variable I had up above? When you click the cancel button, all it does is call the cancel method on that token source. That is basically kind of like a manual reset event where you say set. In this case, we have a cancellation token and we're calling the cancel method, which allows us to trigger an event for all of the threads that are participating with that token source to listen to. So as soon as I say, hey, I'm ready to cancel, I click the button, all of the threads that are listening to that token source will then cancel what they're doing and exit. Okay, let's go to the start button. As you can see here, it is replete with comments, and that's because cancellation is one of the trickier things to do with the TPL. Okay, because there is actually quite a lot involved with setting up that cancellation token, and then in our case we want to be able to monitor for success or failure, and then resynchronizing data output back to the UI thread. So I tried to itemize as much as I could here so you can see exactly what's going on at every step. So first off, we'll do the easy stuff. We'll set up the screen. So when the user clicks the Go button to indicate we want to go download all of those web pages, I turn that Go button off by setting its is enabled property to false, and then I enable the cancel button. Okay, that makes sense. So while it's processing the web pages, we don't want to start off those tasks again. We want to do them independently. So we click Go, and then we're allowed to click Cancel, nothing else. Then I clear out each of those 12 text boxes. This is because we may run this several times in a row, and we want clear indication when the threads are completing, in which case they'll start filling in the text boxes. So I clear each of those text boxes in the array. Now I create a new cancellation token source. Notice here I don't create it up where I define the fields. Notice here it's set to null. There's a reason for this. I want every single time I launch these tasks to have a fresh cancellation token source, because once I've set it to the canceled state, it's hard to get it back into a state where it can be rerun. So this allows me then, if we've canceled or completed, then that token is no longer good. It's basically complete. Don't use it anymore. So this allows us to create a new one every time we start spawning these tasks. Okay, so that creates the new cancellation token source, and again we store it in that class level field. And the only reason we have to do that is because we want to be able to trigger this particular token again from the cancel buttons click event. Next, I want to maintain a list of the tasks that we're going to perform. Pretty simply, we have 12 URLs we're going to process. We will have 12 tasks. So this allows me to group them all together into one group of tasks. Then finally, before we spawn the tasks, I need a handle to the window UI thread. Okay, so in this case, the WPF UI thread is what we need to output all our results back to. If we were not to use this synchronization technique, we would get some cross-threading invocation problems. You're not allowed to do that. So if you create any controls on the UI thread, which we did, to access those controls, any of their properties, you must do so on that same UI thread. This allows us, this task scheduler allows us to get a reference to that thread, so when it's time for us to output the results, we can do it on that thread. Now, it sounds a lot more complicated than it really is. Traditionally, what you would have to do is use the dispatcher with WPF to call basically a delegate to update your values, and that delegate would be invoked upon the UI thread. This will do that in the background. And I'll show you that here in just a few minutes. Next, we spawn the tasks. Now this is where you have to be very careful. It's very easy to forget to do this next little step here. Okay, so we do the for int I equals 0, I is less than the URL's length, basically 12, I++. Now I'm creating this index variable and assigning it I. Okay, and I don't do anything to I anywhere within this for loop. Notice here it goes through, and I don't increment I don't touch I in any way, shape, or form. It is just the looping variable in this for loop. The problem is, if I were to use this I in place of index here, where I'm saying go get this URL or modify this particular text box. Remember, they're both arrays. We have the array of URLs and we have the array of text boxes. If I tried to use I in these places here, the issue is these tasks are running basically with in different threads. So it could actually corrupt the values. Anything that's declared outside of this for loop where each of these tasks are being spawned isn't fair game anymore. It's not safe to use those values. And in the way the for loop works, this I is declared outside of that loop. You can consider it that way. So what I'm doing here is at every iteration of the loop, I'm creating a new variable called index, which will have its own independent entry into the stack. That way, when these tasks are running, we don't have to worry about, like, when they complete, what is the value of I now? It could be done. Okay, so we could actually spawn all these tasks, and then all of a sudden, if we have 12 as the upper bound, we could be accessing 12 for the index and MURLs if we were to use I. That's because this loop will continue to run, continuing to create all of the tasks, but this, for instance right here, this continue with, may not actually fire until this for loop is gone, long since gone. In which case I will still be in the stack because it's accessing it, but it could be beyond the range of the array. So that's why we have to create an independent entry with its own stack value that is going to be used by these particular lambda expressions as we get lower. I know this is a very confusing issue, but anytime you're going to do these lambda expressions, especially if it's going to be asynchronous, in other words, this may not happen immediately. It may have to wait for something else to happen. You can't guarantee any results that were created outside of its parent container. So that's why we create one inside the parent container. So that way all of these values or all of these lambda expressions will get this index and it'll be correct. Okay, so if you wanted to experiment with it, you could of course change this to use I in place of index in all of these calls, and you will probably see when it runs you will get out of the bounds exceptions because I has already completed the for loop before you were able to actually utilize it later on. Okay, enough about that right now. It's one of those things, it's complicated, just do it. Okay, next we are going to create our base task for each of these URLs. So what I need to do is use the tasks factory method to start a new task. There are many different ways to actually start a task. This is probably the most common way. Okay, so we're going to ask the task factory, and we're saying start new, and we want to start a method. In this case, we are going to start a method that accepts no parameters, and the heart of the method is the lambda expression, is going to call this other method called download web page, passing it the particular URL for that iteration of the loop. So it goes, figures out what index is. The first time we hit this, it's going to be 0. If we go back up to the list, that corresponds to, in this case, Amazon.com. So it's going to take that URL and pass it to the download web page method. This method is declared above this particular event handler. So if we were to go up here, you will see download web page is a method we have defined. And again, lots of comments. We'll get to that in just a few minutes. Okay, notice then when I created this task, it had a second parameter. The first parameter is the delegate, or in this case, the lambda expression I wish to execute. The second parameter is a cancellation token. Okay, this tells that task that it is going to participate with possible cancellation. So anytime there is a failure or something that has to be set to indicate, hey, we had a task that was canceled, we'll be able to monitor for that. Next, we take this var, which actually happens to be a task of type string. I just use var because it's the common technique for when you're creating tasks. That way you don't have to remember, to do the task, open brace, string, etc. But it is actually a task string object, as you can see here when IntelliSense pops it up. Okay, we could use either one. They're interchangeable in this particular case. If I had a different type of task, obviously it wouldn't be a task of string. Okay, but we're adding that to the task list so we can keep track of it. Then we are going to do one of two possible things. Notice here we are going to take that task called compute, and we're either going to continue with and do this code if it runs to completion, or we'll do a continue with this particular code when there was a cancellation. Okay, let's take a look at each one independently here. As you can see here, we have, again, task of string. We could have used var again. Display results. That's the name of my task. Okay. Then I'm going to say the compute task, continue with. So basically, we've already spawned off that task. It may already be running. It may not be complete yet. It might be complete. But what we're saying is, once that particular task completes, we want to continue with this code. Notice here I'm using a lambda expression because I just want to do a simple assignment into the corresponding text box, whatever the result of that task happens to be. This result parameter is common for all task types, and it happens to be whatever data type the task is. So in this case, we have a string task, so result will be a string. So we're going to take the result of the thread or the task that just completed and put it in the corresponding text box. Okay? We're going to say, we're not listening for cancellation here, it's just do it or don't. And the do it or don't portion is going to be decided by whether or not this task, compute, ran to completion or not. So we're saying after compute completes, continue with this method only if it ran to completion. Look at the final parameter. That's where we pass that UI. Remember, this was the handle we defined up above to indicate the resynchronization for the UI thread. So that's going to store that value. So it'll execute this Lambda expression on that UI thread. Now, the next code is virtually identical. Notice here, it's again a task of type string, display canceled tasks is the name. And if you look here, we're not actually really using that name anymore. Okay? As a matter of fact, we don't even have to store the output for these continued with unless we wanted to do something further with those tasks. It's just common practice. It returns a task of type string, so we'll create a variable to hold it. Just be aware, compute, continue with again. This time, we're going to put canceled in the appropriate text box based on the index. Again, we're not monitoring for cancellation this time because we've already completed our main task. And this time it's only going to run when it's canceled. Now, if you hit the special key, mine set to Control J to list the members of that task continuation options, you will see there are many different types of options. Okay, so we have only on canceled, only on faulted, only on ran to completion. So we could also monitor for exceptions, like for instance, I put in a bad URL, it might come back with an exception to indicate that it couldn't find the appropriate value, etc. I'm only interested in cancellation and run to completion in this particular case. So I have only on canceled, again, resynchronized on that UI thread. Now, these will not run for the same task because these are going to be mutually exclusive. It either ran to completion or only when it's canceled. And as I said before, let's say our task that we started up here for the download web page, let's say it's a 5-minute task. I know it's a little strange to say that because it's just downloading a URL, but let's just pretend. It's a 5-minute task. What happens is we start that task, immediately we add that task to the list, and then immediately after that, we set up the continuation options. If it completed or if it canceled, it'll do one or the other. And then in the meantime, that task is still running. So it would still continue through here and then go to the next iteration of the loop to spawn off another task for the next URL. So as soon as all of the tasks have spawned, we have a couple choices we have to make. Do we want to just let this method finish, or do we want to wait for completion? In this case, I want to wait for completion because when it is done, I want to set those buttons back to their initial state so we can kick off the tasks again. So what we're going to say here is wait for all of the tasks. Remember, we created that task list. We add each of the tasks to that list. And we're saying when all of those tasks have been completed, execute this Lambda expression. Again, we're just going to set the go button to enabled, and the cancel button is not enabled or disabled. We're not monitoring any cancellation token. We have no task continuation options, but we do have to resynchronize back on the main UI thread again because there is a chance that we're not on that thread at this point. So basically, we are going to sit here on this method until we have completion one way or the other of the main tasks. Okay, let's go back up here where we actually spawn the new tasks. Remember, we call this download web page method, which is the heart of the task. This is basically the method that we're performing for the main tasks. We pass it the URL, convert it into a URI. It's just a more object-friendly version of the URL, which will parse the URL into its pieces, and it allows for basically, it takes one step away from the methods that's going to actually do the downloading of the pages. So if we go look at that method, Again, like I said, you'll see a lot of comments. So this is one that we generated. It's called download web page, and it accepts a URI. Okay, again, the URL's address that we're going to execute. This time, inside of this method, because we are going to do yet another asynchronous operation when we ask for the web page, we are going to monitor that with a task completion source object. Notice here again, it's of type string because we are going to be looking for a string upon completion. Also, we want to indicate and monitor whether or not that source token, remember that cancellation source token we created, we want to monitor whether or not a cancellation has occurred. So if someone clicks the cancel button, we want to be notified and throw an exception in here, which basically will stop the processing. Now, to download a page, we're going to use the .NET's web client class. You'll find it in system.net, as you can see there. And we're going to put it in a using clause because it does have resources we want to dispose once it's completed execution. And we do the using clause because that allows us to clean up that object whether or not we fail or succeed. Now, this is where things get a little funky, so please pay attention. This client object has a method called download string async, as you can see down here. There's also other methods that you can call. For instance, you can just do download string, which is going to be a blocking version. Okay, but I want the asynchronous version. So in this case, what we're saying is download using that address, but do it asynchronously. Now, when download string async completes, it fires an event known as download string completed. Normally, you would see client.download string completed plus equals, and you'll point it to some event handler method. In this case, we are going to do that in line with the Lambda expression. So above the call to start download, okay, here's the download string async. Before that, I define that event handler. So here we're saying the client, again, it is going to be that web client object, download string completed event, and we're going to add to it this Lambda expression. So normally you'd see plus equals, and then you would see some method that matches the signature for that event. In this case, the signature is here, sender and args. That's typical for any event handler. Sender is who sent it, args are any arguments that are going to be passed to the event handler. But instead of redirecting it to a concrete method, we're redirecting that event to this Lambda expression. Okay, I put some notes in here what args is. It's the download string completed event args, which inherits from async completed event args, which all the way down goes to event args as far as the base class goes. And then some of the properties. We have result, canceled, error, and user state. We're most interested in result, canceled, and error. We don't have any user state in this case, but we could have put, like, say, the URL or something in there. Okay, so what we're looking for is whether or not we've completed. Okay, so if it completes successfully, no exceptions, no problems, what we're going to do is this else down here, okay, where we say the task completion source object, remember that's the thing that we're using here, that's going to be monitoring for cancellation, etc. Set the result, and the result comes in this args object. Remember, this is a download string completed event args. Well, that args contains the result property, which is going to be, in our case, the HTML source of the web page in question. Okay, so that's on success. However, that's not the only possibility. If args.error is not equal to null, that would be an exception that's embedded within that event arguments. All we're going to do is take that task cancellation source object and set the exception, passing it that error. Now, if it was canceled, again, we'll be able to see that with the canceled property. We are simply going to set the task completion source to canceled. Okay, so those are basically the three possible outcomes for that particular task. Okay, in this case, what's the task? The download string async. So those are the three possible outcomes. We either set an exception, set canceled, or set a result. So what we do then is put that task in a wait state. Okay, so we're saying tcs.task wait. Now, notice that this TCS was in no way ever attached to this client.downloadStringAsync. Okay, if you look around, it's like, I don't see that anywhere. Okay, we create the TCS up here. Okay, great. There's the TCS object. But the next time we see TCS is within the completed event for the download string method, where we say set exception, set canceled, and set result. So what this TCS object, when we put it into the wait state, it's basically working very similar to a manual or an auto reset event. It's waiting then for one of these set methods to be called on it to indicate it is done. So when it is done, we simply take the result of the task and return that. Now, if the task fails, result will be null or empty. Okay? So that is another way we can monitor tasks that we did not write. If you look here, download string async is not something we wrote. That is something that's part of the .NET framework itself. But that doesn't mean we can't enlist it as a task. So we're going to take this method and use tasking to monitor its completion with this task completion source object. And just so you know, you can use the task completion source object with a standard, a standard thread pool object as well. It doesn't have to be a task. It can be any asynchronous operation. Only thing that has to happen is that asynchronous method has to have access to that TCS object. Oh, and because we did this inline, notice here we don't declare TCS anywhere as the input parameters of this basically anonymous delegate lambda expression, but because it's declared within the same scope, it's able to see that. So it allows us to be able to use TCS within this. So behind the scenes, when it creates the method, it's actually tacking it on as another parameter being passed to this inline method. Okay, so as we looked before, when the task is completed, as long as we didn't cancel, what happens is we will take that value that was basically completed from that compute method. Remember, compute is pointing to that download web page. It takes that result, and remember, that's what we put in here for the return value. And that's what we put into the text boxes. Now, this, like I said, is probably one of the more complicated examples of using TPL. However, it should give you a good framework for doing cancellation and resynchronizing to the UI thread. Those are the two most complicated things that you will probably ever do. Okay, and you can take this framework and do it with other methods. Like in this case, I just so happen to start a task, and the task calls another asynchronous operation. That's not always going to be the case. Your task itself, like this download web page, may be a very synchronous operation. It doesn't matter. Think of it as a black box. It's just a method that returns a string. Okay? What that method does, since it's using asynchronous calls within the download web page method, that is entirely black box because it'll synchronize within there and it waits to return the appropriate value. So as far as the parent task is concerned, when we spawn it here, when we say start new, it's a synchronous method. So basically it is a thread. Yes, it spawns another thread, but again, it doesn't matter at this level. Okay, let's run the code. And I'll put the window on the screen here. And you will see that we have those 12 text boxes. If I click Go, you'll see at various times the source will be downloaded and put into those text boxes. Okay, now some of them look blank. Okay, we have an exception here. What was that? One or more errors occurred. Okay, let's check here for exception. We had the 404. Okay, I wonder which one failed. Let's take a look here. Let's take a look at address. Aha, so the Windows Phone website failed. Okay, well, because I have it to break on any exceptions, we didn't allow it to complete all the way through the end. So let's go ahead and fix that. Instead of doing Windows Phone, let's just set it to, let's just set it to something else, maybe ask.com. Okay, just to make sure we get all completion. We'll worry about the exception cases later. Again, I'm going to bring the window to the foreground here. We'll click Go. Okay, this time we have the source for each of the different web pages. You see they all executed. Now to demonstrate cancellation, what I want to do is click the Go and then click Cancel. I guess I didn't click it quite fast enough. Let's try again. The problem is I'm working on a machine that is extremely fast, and all of the tasks were able to start before the cancellation token could be processed. So let me stop, and I'll hit Run again. Flush the cache. There we go. So that's the problem when you're running on a basically a quad core with hyperthreading enabled. It's able to start each of the tasks, and once it started the web page download, it's basically out of the task's hand. So you can see here I was able to quickly cancel. It was able to spawn off all the previous 8 threads, and then I canceled it before it could get to these 4. Okay, so that is an example of cancellation. Now, if you wanted to, what you could do to make it life a little easier to see the cancellation actually work is you'd probably want to put some kind of sleep within the tasks. So you could actually go in here and spawn the tasks, and on this Start New, what you could do is put a little sleep right there, and then have it sleep before it tries to download the web page. That way you can get some delay so you don't have to quickly click Start then Cancel. Okay, so that's the basic demonstration of using the TPL to do the asynchronous tasking. Now, there are many simpler examples, and I highly recommend you take a look online for some other TPL examples, because there are many different ways to do the same type of operations. Okay, this is just one example I wanted to give you so you can play with and start to understand the behavior of, first of all, using cancellation tokens, and then the other thing was synchronizing back on a UI thread with task continuations, as I showed you here. So basically finish the task, and when it's done, continue with this, etc. Oh, and by the way, if I needed to, and I wanted to continue again from either this task continuation or this one, I could again do, like for instance, display result dot continue with, and then continue after that is complete. So each task that has a continuation can be a continuation in itself. So you can do that as many times as you need until your task is complete. So that pretty much covers the demo. Again, play with it, see what you can learn.